Okay, 8th grade, we are working on 2.6. You should be working on your warm-up. Hopefully you have just about completed it by now. All right, 8th grade, I'm going to help you with these warm-ups just to refresh your memory. 9x plus 6 equals 8x minus 1. 9x plus 6 equals, woo, that was a giant equal sign, equals 8x, right? Minus 1. Okay, so it says solve for x. So all you have to do is combine like terms, remember? So let's move the stuff that needs to go on one side and then move the others. So let's move this 8x over here. Why would I choose to move the 8x? Because it's smaller. So my answer is not going to become a negative. So I'm going to subtract 8x from both sides. Just line it up with like terms. What is 9x minus 8x? I'm left with just an x, right? Okay, now let's move this positive 6. How do I move plus 6? Subtract. Okay, so then I have a negative 1 minus 6. Goes further negative to be negative 7. So my first answer, x equals negative 7. Okay, will you read the second one to me?
Okay, I got you, man. Hold on. It's loading. Okay. Negative 18 minus 5.7x equals 16 minus 7.7x.
Can't write that fast.
Okay.
Negative 18.
Minus 5.7x.
Okay.
Equals 16 minus 7.7x.
7.7.
Yes.
All right, so again, let's combine like terms. Let me finish this. So, should we move the 5.7 or the 7.7?
5.7.
It doesn't really matter. But yes, let's add, since it's subtracting, we're going to add 5.7x. So plus 5.7x over here. It does not matter what side of the equal sign the x is. The point is to get the x by itself. Okay, so those cancel. What is negative 7.7 plus 5.7? Is he right? 100%. There it is. And it's a negative 2. This was greater. So it's a negative 2x. Okay, now let's move this 16. Is this 16 positive or negative?
Positive.
Positive. So how do I move it? By subtracting. So negative 16 minus 16. So what is negative 18 minus 16? It's going to go further negative. Negative 34. Okay, now to get the x by itself, what do I do? Divide by negative 2. So the negatives cancel. What's 34 divided by 2? So 17 equals x. Or x equals 17. Okay, does that make sense? All right, so now everybody should have 100 on their warm-ups. Okay, so we're going to talk about similarity, transformation, and similar figures. So when you do a dilation, that was the last lesson we learned, it does not preserve length, right? Because you're going to expand the length of your side or reduce the length of your side, right? Say right.
Right.
Thank you.
Left.
Not today, guys. So dilations are not considered rigid motions because things change. A similarity transformation is a dilation or sequence of dilations and rigid motions. You saw one of them in your self-assessment, I believe it was. Two figures are similar figures when one can be obtained from the other by a similarity transformation. Similar figures have the same shape but not necessarily the same size. So if you look at these two triangles, they have the exact same shape, and you can see how they have corresponding angles, and we mark them. Angle B is corresponding to angle E, which means they're congruent, or they're equal to each other. A is congruent to D, C is congruent to F. Make sense? This makes their sides not equal, but proportional. So they're not going to equal the same length, but you can write them as a proportion, as you see here. AB is proportional to ED. BC is proportional to EF, and AC is proportional to DF. Okay? Proportion means if I were to write them as a fraction, this side over this side, it should equal a reduced version of this side over this side. Okay? Questions? All right. So let's go do example 1. Put this in your journals. Yes, I could give you just a moment to finish that. All right, so we're going to determine whether triangle ABC, the smaller one, and JKL are similar. Already you can tell this is what kind of transformation? Elena? A dilation, specifically an enlargement, yes. So we're going to look at this and see if we can figure out whether the vertices and the sides would be considered corresponding. So compare the coordinates of the vertices. We have A is at 0, 3, J is at 0, 6. What happened from 0, 3 to 0, 6? Elena? It was multiplied by 2, because 0 times 2 is still 0. 2 times 3 is 6. Now let's see if the same thing happens for the other coordinates. So B is at 3, 3, and it moves to K at 6, 6. What type of math happened? Elena?
Multiplication.
Yeah, but what do we multiply by?
2.
2. So far are we the same?
Yes.
Shh. Yes. And then the last one, we're at 3, 0, and we go to 6, 0. Did we again multiply times 2?
Yes.
Yes. So far the vertices would be considered corresponding, right? Thank you. All right, so now let's look at, yes, we know it's a dilation scale factor of 2 because we multiplied by 2. Oh, we don't even have to look at the sides? All right, all you had to do is see if the dilations worked. Okay, another thing you could look at, let me just show you here. Can I draw on this? I think I can. Yes. So if I count A to B, I have 1, 2, 3, right? And then this goes 1, 2, 3, 4, 5, 6. So this is 3 over 6. That's my ratio there. Now if I compare it to this other side, 1, 2, 3. 1, 2, 3, 4, 5, 6. Again, it's 3 to 6. So I could compare those ratios. 3 to 6 equals 3 to 6. So far, are we corresponding on the side lengths?
Yes.
Yes. You could even do it to the horizontal one. So if I did 3 to 6 on this one, and then we go this way, 1, 2, 3, 1, 2, 6, 3 to 6 this way. The trick is the diagonal ones aren't true measurements. They actually measure 1.5, but the ratio is the same. You can see it was 3 to 6 both ways. You can even reduce that. It'd be 1/2, right? 1 to 2 both ways. All right. Go ahead and do your triads. Okay, you're doing triad number 1. All right, 8th grade, here is example 2. The red figure is similar to the blue figure. It tells you that. Okay, so you already know things equal things, yes?
Yes.
Describe a similarity transformation between the figures. Well, already, what's the biggest thing we notice? Josh.
There is a reduction.
Red,
is bigger. It's red.
it's an enlargement because you start with blue. But yes, you were just going the other way. Start with blue, go to red.
It's usually red.
Where? So this would be an enlargement. Red figure is similar to the blue. It might be red to blue. It is. He is correct. It's red to blue. So from red to blue is a reduction. Okay? And it's about half the size. So your scale factor is going to be 1/2, 1 to 2. Okay? And what else happens? Yes? There's a rotation. Okay? Or, see how it reduced 1/2 here? Once it reduced, what can we actually easily do? Reflect. Very good. Across the x-axis. Okay? Everybody follow that? So we did a reduction, and then we flipped it across the x-axis. Pretty simple, yes? Any questions? Okay, in your journals, you just say the red figure reduced by 1/2 and reflected across the x-axis. Okay, and then you can go try it number 2. 8th grade, put this in your journals. Last example 3.
Okay.
An artist draws a replica of a painting that is on a remaining piece of the Berlin Wall. The painting includes a red trapezoid. You can see it over here. The shorter base of the similar trapezoid in the replica is 3.75 inches. So here's the replica. What is the height of the trapezoid in the replica? So first of all, it tells us that these are similar, yes? So that means we can find the length of h by comparing what? Anybody got a clue? Ratios. So I can set 3.75 over h equals 15 over 12. I don't know if that's the way they did it. We're about to find out. They did it opposite. Okay? So we did 3.75 over 15 because these are the two corresponding sides, right?
Yes.
Write this down. Okay? And then we again choose the smaller trapezoid, h over 12 being the second half. Okay? There's several ways you can set up this proportion for it to work as long as you always start and end in the same pattern. Okay? So now I have 3.75 over 15 equals h over 12. Can I solve for h? Yes. Do you guys remember how to solve? Obviously not. Cross, multiply, and divide. So what's 12 times 3.75? Divided by 15 is? 3. So the height of the replica is 3 inches. Write that in your journals, guys. All of this. Cross, multiply, and divide. Okay, and you can just do the little, you know how I draw circle 3.75 times 12 divided by 15? That's fine too. All right, so this is how you solve for, you just put them as a ratio. Or proportion is another word. Any questions?
No.
You have the hiccups? I'm sorry.
No, I have the uptick.
Good try.
Okay.
Not funny.
I thought it was.
All right, do your last self-assessment. Is that it, 5 through 7?
Yes.
Short lesson for you guys. All right, once you're done with that, you're done for today.